Hello, everyone. Thank you all for joining. Welcome to the InRhythm Technology Summit for summer 2023. I'm Parag Katkar. I'm the head of consulting practices at InRhythm. To those who are new to InRhythm, we are a modern product and technology consulting firm that helps large financial enterprises with their digital transformation journeys. And we have launched more than 100 enterprise products working with 100 plus teams. One of our core value is learning and growth. And the thought leaders at InRhythm constantly keep identifying the latest trends in the industry. And over next few weeks, we will be hosting a series of 6 hands-on interactive coding workshops on some of the latest technology trends. And today we are hosting the second workshop of this series, which is a deep dive on Next.js. We'll explore what an incremental adoption approach could be for your applications. We'll also learn some of the features like lazy loading and code splitting within the Next.js framework and demonstrate how these features could improve your SEO performance. So without further ado, I'm going to hand it over to Kevin Manjalo to kick it off.
Great, thanks, Parag, and welcome everybody to the Q3 Web Summit. I'm really excited to be here with my co-hosts, and I'd like to welcome you to the Next.js workshop, where we'll unveil the power of modern web development. In this dynamic and informative session, we will dive into the realm of Next.js, which you've already heard, which is a cutting-edge framework that's reshaping the way we build web applications. And over the course of this workshop, we will be exploring 3 pivotal aspects that will elevate your development skills and empower you to create blazing fast, SEO-friendly, and highly efficient web experiences. We have 3 separate topics today that we're going to be covering in depth. The first topic is converting a React app to Next.js. So in this section, we'll embark on our journey to unravel the seamless transition from converting a traditional React application to the world of Next.js, and discover how Next.js simplifies the development process, enhances code maintainability, facilitates server-side rendering for an instant loading experience, and through hands-on demonstrations and practical examples, you learn step-by-step how to harness the power of Next.js to transform your existing React projects into modern, performant web applications. Second topic that we're going to go into is leveraging some backend capabilities of Next.js. So delving deeper, we'll unveil the backend capabilities that set Next.js apart from its peers. You'll gain insights into server-side rendering, API routing, and with these capabilities, you can effortlessly create APIs, handle data fetching, and so on and so forth, integrating them seamlessly with your front end. And through this interactive exercise, you unlock the powerful potential to build feature-rich, dynamic web applications that offer unparalleled user experiences. And last but not least, our third topic, we will be going into performance improvements. So you're going to learn about SEO, lazy loading, and code splitting. These modern web demands, exceptional performance, and Next.js delivers. So in this section, we'll delve into the trifecta of performance optimization, lazy loading, and code splitting, and more, even more beyond that. So witness how Next.js empowers you to effortlessly optimize your application for search engines through smart code splitting, and ensure that not only the necessary components are loaded when needed. And armed with these techniques, you'll be equipped to create high-performing websites that captivate users and search engines alike. So whether you're an experienced developer looking to upgrade your skills or a newcomer eager to master the latest in web development, the Next.js workshop has something to offer. So thank you for joining us as we demystify the transition to Next.js and unlock all these other capabilities that we've mentioned. Let's get ready to embark on a journey that will shape your approach to modern web development. I mentioned my great co-hosts, Paul Platowicz and Bhavan Kuchibatla. Paul is our senior software engineer, and Bhavan is a lead engineer. And we're going to start with Paul. So I'll pass it off to Paul, and we're going to go into converting a React app to Next.js. Take it away, Paul.
All right. Thanks, Kevin. Server-side rendering React with Next.js. It's front-end development with a server. If this sounds different, it is. This newer idea is becoming more and more popular. We are going to be thinking about building front ends in a different way, because now a good portion of the React code we write can run on the server. If you haven't yet formed an opinion about React server components, maybe today is the day. We're going to review our current options for delivering UI to the browser. We're going to talk about what React server-side components are. We're going to learn the fundamental ideas around using Next.js to help us server-side render our content with React. And then we're going to mention some performance benefits in depth at the end. But yeah, let's review the common ways to deliver content to the browser today. First and foremost, client-side rendering. This is what we're used to. Think single-page applications. Think having JavaScript add elements to the DOM dynamically. If you were to review this content in the network tab, the preview, this is what you're going to see. When you hit the URL, this is what the preview is in the network tab. Blank if it's a single page application. So all the elements are going to be added to the document object model after the JavaScript loads in the browser. So you can see why this might be hard for search engines to understand what your content is about and why people should go to your page. Next is server-side rendering, which has been a part of the web for a long time. In the early days, we had just pure static HTML files, but dynamic web pages came shortly after that. Just think the first version of PHP came out in 1995. Actually, so did JavaScript. But server-side rendering is not a new idea. But using React to server-side rendered content is newer, and that's where we're going to go into in depth. So modern server-side rendering right now is how it normally works is that you use a templating engine with your backend framework. So let me just give an example with Express.js. You would create a route, just like here's just the entry route to a page. Data would be gathered on the backend. For simplicity, I'm just defining a data object here. But then you would specify a template of some sort, and you would pass that data to the template. And that's how you could get dynamic content to the client. So over here, you can see we're using the page title, the message. Also recognize that you're including the JavaScript yourselves, or you're managing the JavaScript within the template, whether it's in the same file or you're going to include another file. That burden is on you. But another thing to realize is that when you hit an endpoint, the server is going to gather all the data, return the template, which is going to be rendered HTML to the browser. That's going to happen all in one go. You wouldn't be able to have like a loading state or something in between while a data heavy process is happening on the server. You would have to wait. So we're going to see how Next.js can help with that and give you more options for server-side rendering. Also, there's static site generation. This is when you're at build time creating all your HTML files for each path of your application. This works great for marketing content. But we're going to see how server-side rendering can give you some extra options, and it's not going to be as fast as static site generation, but it's competing with it. Next.js can also, if you don't see yourself needing a lot of the server-side capabilities, Next.js does have a way to statically generate your site, but we'll get into that later with performance. Next.js is server first. This is their philosophy. For example, when you're creating React components within Next, they will be server components by default, unless you mark them as client components, and we're going to get into that. But just know, like, everything is constructed in a way to be rendered on the server as much as it can. So React server components, it's actually part of React itself. It's new with React 18. They're utilized to build hybrid applications so we can leverage the server and the client, and we're going to go into depth about that. It's still considered experimental, but it will be in a future minor release of React 18. And this is how we're able to use them today with frameworks like Next.js and other frameworks as well. Okay, so we got to start thinking about constructing our applications in a slightly different way. We're going to think about what actually has state at the browser, what needs browser APIs. If it doesn't need those two things commonly, that's like the two rule of thumbs. If the component doesn't require state or doesn't require browser APIs, we can make it a server component. So you can see the sidebar. Chances are it's some links. That's something we can generate on the server. The nav bar as well. A lot of that content is going to be more static. But you can have a client component within a server component. And you can see the search bar here. That's something that does require interaction, or it needs to be interactive. So when we specify a component as a client component, Next.js can send JavaScript to the browser for that individual component. So we're able to have our React code render and then return more of the HTML complete than we otherwise would with all client-side rendering, like we saw before, with just a blank preview of the HTML or what the content's going to be within the client. Okay, so let's review this. We had a slight overview, but a server component, if it just needs to fetch data, we can do that on the server. If it needs to access backend resources directly, that's fine. We'll do it on the server. Just think we have access to Node.js, so it's possible to even have your database next to the framework on the server, or maybe even like Redis or something. Whatever's on the server, we can access. But all these data-heavy calls we can do with Node on the server. If you want to keep sensitive information, that's also a great use case of using a server. Large dependencies, let's not send that to the client if we don't have to. We'll keep it server side. But if a component requires interactivity, we want to mark it as a client component. This is where the directives come in. By default, like I mentioned, all components are going to be considered server components. So, I mean, you can specify a component as a server component by using this directive, use server, but you only have to specify the client one. So if we do have a component that is interactive, we'll add use client to the top of the file. If we're using state and lifestyle effects, yes, we're going to need to have that be a client component. Same thing with browser APIs. Chances are your custom hooks are using state, so that will be a client component. And then this is a big one. If you have a code base that still uses React class components, we'll have to mark that as use client. So keep that in mind if you're still working with an older code base of React components. that uses class components. Okay, we cannot utilize a server component within a client component. We have to use a little bit of composition to do this. So how this works is if you need to pass a server component to a client component, you can access the children or utilize children from props and then place where the children will go. And then this is how you get around actually passing a server component to a client component. This is a little edge case that I wanted to cover, but just keep this in mind with the code along. Of course, I'll help you along as well, but this is a good concept to know. Okay, the biggest leap we have to make is how is routing going to work with Next.js? We're used to using client-side routing solutions like React Router, but we're not going to have that on the server, and it doesn't make sense to have a solution like that. So in place of that, we're going to have file system-based routing. We're going to create directories and include certain files in order to define our routes within Next.js. Each path segment matches the folder name. And I'll show you a picture of that in a second. There's a way to create layouts, nested routing, loading states, error handling, and more. We'll get more into this as well. But you need to make sure that you have the correct files within the correct directory, because that's how routing is going to work. A little side benefit, since creating routes is a very structured, defined way within Next.js, this is going to make React projects more consistent compared to with regular single page application React projects. You can define your routes in, well, they're usually in the app component file, but the rest of your components can be anywhere and set up in any way. This is going to be nice for jumping around in code bases with Next.js because you're going to know where to go to find out where's the code for a specific route. Okay. So there's going to be an app directory, and then within it, you create directories for your routes. So actually here, dashboard is the example of the route we will be creating. It will be /dashboard here. But I just want to mention some of these extra files that we can include. So layouts, you can create a route layout that would include like HTML and body elements, like the basic setup to an HTML file. And then there is nesting for layouts too. So within your dashboard, like the layout component will wrap the page component. So you can imagine you can create hierarchies of layout, and don't get too overwhelmed by this. This is also kind of a newer topic. We do sometimes do this with React where we're wrapping children with a component, and that's adding more to the component. That's how layouts work. There's nesting, and you can build your layout as you go through the directories. So page.js, this is required for the directory to be reachable by the client. To actually create the route, you need page.js, and then you will use all your common React components within page.js files to create the pages. Loading.js is a fallback UI that can be shown by Next.js when Next.js is fetching data. How this works, it's using suspense. And so when you hit the route, Next.js will, by default, automatically deliver the loading content. And then when the data completes fetching on the server, then it's going to be able to replace that content with the real content you wanted to display. And then error.js, similar to loading, but it's the error scenario. But let me give some more examples here of how you can like set up your routing. So like here you would have app, dashboard, and then within dashboard there could be settings. So it would look something like this. So you can see how the directory directly maps to the path names you want to have within the URL. Something that's cool, I liked this feature a lot. Just because you create a directory and you include some JavaScript files within that directory does not mean that it's available to the client. You have to have page.js within the directory in order for that JavaScript to be reachable or routable and available to the client. So you can place your common React components next to your pages. Like here's a good example of using constants. You can still have that within the app directory and it's not going to be leaked to the client. Okay, so migrating to Next.js, let's assume we have a React single page application. You're going to use this npx command to create the new application. You're going to make sure you install the required dependencies so that they're the same between the projects, but now you want to start creating your routes like you had with your other project. So you'll do what we just talked about, creating a directory, making sure you have a page.js file, etc. But then I recommend, since your single page application probably has a lot of state with each component, you can mark each component as use client at first, and then we can work to make it so that they're server components. So that's why I put this here. As you're migrating, feel free to use the use client directive until you fix things so that it can be a server component. We'll have to update the imports and fetch requests. We'll get into this more about like data fetching on the server, but as a little sneak peek, we can get away from using use effect and just write regular fetch requests and save it to a variable and use it. We don't have to use use effect. So a few difference there. And imports, as you're moving your files around, of course, you're going to have to update those. Yeah, you can use layout files in place of layout components. I'll talk about this more when I show you the project I created for us to do with the code along. Update navigation to use Next.js link components or the use router hook. So most of us are using React Router DOM probably for client-side routing. Their component is nav link. Next.js's component is link, so I have to update that. And then if you're going to programmatically change routes, then you have to use a different hook than what's provided by React Router DOM. This one is optional. Chances are you won't have to change any of the Next.js config file, but say you're doing something special with Webpack or something, there are times we have to update the config, but we're going to consider that optional until that's required. But yes, for now, let's start to refactor a single page application. I'll show you what I built. It's a very simple application to migrate, but let me just show you like where to pull the code, and then also I'll show you how to create your first route, and then just to give you some more context so that you can go about this on your own. All right, guys, so I'm just going to pull down the repository. Oh, let me just set something up. Let me start over again. Okay, so then we're going to pull down the repo and open it in your favorite editor. Now there's going to be 3 projects included within here. I have the old or the single page application we're going to be refactoring. I have a Koa REST API that's just to have our backend working so that we can actually build something. And then Next.js. I took the liberty of initializing the project for us so we don't have to worry about getting rid of filler content. I made sure the dependencies that you need are already in the project. So no worries there. But let's show you the single page application I have for us to rebuild. So first we need to install the dependencies. And then npm run dev. Those are going to be the commands across the projects. I made them the same so that it's easy. So okay, and actually I do have to do this for the backend so that the application is going to work. So let me do that now. Okay, so npm install here as well. And you don't have to look at the backend code for now. We will create a REST endpoint in the next section. So only worry about just having it running in the background. But okay. All right, so this is a simple application I built for us to try out. Sign up. Let's just create any user you'd like. Okay. So it's just a simple way to add books from some top trending books is what I built. So right now you don't have any books. You can add some. This one is hardcover fiction, lessons in chemistry, maybe happiness, invisible hour. We'll switch to maybe Ring of Fire, full package. Okay, so after we add some books, we can go back to the dashboard and we'll see them listed. We can delete them. A simple CRUD application to rebuild. And then we can log out and then log in again. So that's all the surface area of the application is. But let me show you the good stuff where we'll start creating routes in Next.js. So I'll just make the first one and then you guys can take it from there. But right here within the app directory, you can see this is like, there's no other directory at the moment. That's the only one we have. So we're going to create a new file, or actually a new directory. We'll call it login. That's probably what we want to start with. Then we're also going to come over here. Within the single page application, I have app.js, React Router DOM. The routes are defined right here within the app component. And then we'll go to components. I have the pages here that I'm using for React Router DOM, and then all the common components are in a single folder. So here is the code for the login form. So I'm actually just going to copy this And then we're going to put it. Okay. So I didn't realize, I forgot to mention we created a login folder, but now we need a page.js file. It has to be named page.js. Okay. We're going to paste what I did, and then let's also include the other components that are common to it. I'm just going to copy and paste them right next to the page. That's what's nice. You can keep your common components, unless these are used by other pages, we can just keep them together. And then these are not accessible by the client themselves, just the page, whatever we include in the page. So we need to start importing these components. And one thing that's kind of cool, like Next.js comes with a way to stop from using .. to find all your components in various directories. They have this way of using the @ sign, and then you're within the directory to start using like app and then wherever your other components are. So that's kind of cool. Okay, and now but I'm using a login form. I realize I'll start installing the dependencies. I realized I didn't do that. Okay, so I'm using Formic and a couple other things, but you can see here React Router DOM. I need to replace this with it's called link from next navigation, actually next link. Okay, so we gotta make sure we have that import. And then also, we're going to use router, and this comes from next navigation. Okay, and then so we need to come over here, and anywhere where we're using use navigate, we'll use router instead. Okay. And I think it's Next.js uses router push instead of just having a function that you can call with an argument. So we'll do next push. Okay. All right, so actually this one, I didn't have any links. I just used the way to programmatically change routes. So, all right, let's see if this renders. npm run dev. And I have this on port 3500. And we'll see hello world, because I didn't do the home page yet. I just did the login one. Let's go there. And guess what? I didn't include the use client directive. So let's do that. So I'm using state here. Formic uses use context. So this has to be a client component. Let's refresh. And we're getting, I should have showed that error message a little longer, but it'll tell you that, hey, you're using use state or something else. You need to make this a client component. But you saw that the general approach to refactoring is coming over here, copying the code for a route, moving this to a page.js file within a directory for that route, and then updating how updating the React router linking to Next.js linking. But that's just for context, so you guys have a general way to get started for the code along. Feel free to start pulling down that code, installing the dependencies for each project. And then anyone have any questions so far from this demonstration?
Yeah, I still see the hello world on the 3500 localhost. What did I miss?
Right. So I didn't start with the homepage. I actually started with the login page. So you can see within the app component here, if there's no directory and there's a page.js file, this is going to be like the home page. So this is the code you'll change for just your slash path name, just plain slash. So yeah, next I'll probably do that. I'll go start copying some of the code here.
Oh, the login, the slash login was what I was missing. Okay, thank you.
Oh, okay. Okay. All right. And then here I need to update the link, but let me just comment this out for now. Okay. So then you're starting to see more, and then including the nav bar and stuff, that'll come with its own challenge of updating the links and stuff, but correct. Yeah, that's how it works.
So right now we're just migrating every page.
Yes, I recommend starting with that login page and then the home page, the nav bar. We'll see how far we get or how much we can get done. Don't feel like you have to complete everything. When I realize for the link component for Next.js, instead of 2 for React DOM, we have to use href. So there's a minor difference here, but yeah, and feel free to use client at the top of files for now. We'll go into like data fetching later, and we can try and make them server components. But for now, if you're running into any errors with Next.js, try to use client at the top.
You said instead of for the link instead of to attribute, what do you use?
Oh, right. Yeah, it's href instead of
Okay,
the
thanks.
to property. Yep.
Do we need to duplicate the centered layout to every folder, or was that what use client avoids?
All right, from the spa centered layout. What we could do is use the layout files. So sorry, do like here's layout.js. We didn't go too far into this, but if you want to wrap like all the children, which would be, since this is the root layout, it's going to wrap all the other routes and the pages within those directories. So you can either try and reproduce those with layouts, or it's fine if you just copy and paste the divs. There's not a lot of going on those layouts. If you want to just, for example, just take this and just for now until we play with more layouts, if you want to just wrap it. I was thinking about just doing this for now.
Gotcha.
You
Thank
can do it either way. You can use the layout files, or you can do it this way. While you guys are going, I'll mention one tip. Right here within this nav bar, all the state seems to be around logging out. So really I can create a log out button and then remove that, like the browser APIs that I need, just so it's contained within the logout button. That'll make the logout button a client component, and then you can keep the navbar a server component. But otherwise, feel free to just add the use client directive. But you want to think about like you want to have as many server components as you can before a client component, because once you define a use client, or once you define a component as a client component, all of the components below it in the tree are now going to be client components. So There's even more of a benefit to breaking your application up into even smaller components, because chances are your interactive components can be more towards the bottom of the tree, if that makes sense. So once you say it's use client, then all the components within are going to be considered use client.
I'm getting a 404. Was I supposed to use links somewhere in the sign up page?
Yes, instead of what sign up page? Okay, so sign up page, are you able to, or did you start the Koa REST API?
Yeah, it's I didn't have to make any changes to it, right? But it's
Right,
active.
okay, you did install and run dev, okay.
Yeah. Mm-hmm.
But you're getting it from the fetch request, or are you getting it when trying to visit the page itself within the browser?
When trying to, through localhost 3500, and then I click the sign up button and it goes to 404.
Okay, is there a page.js file within the directory?
Mm-hmm. Yeah, there's a page.js, sign up form.js and standard layout. I just like duplicated it for now
Oh,
in
okay.
the sign up folder. Directory name need to be sign dash up.
Yeah, it'll be whatever you name it. So
Doesn't
I
matter.
did sign dash up, but if yours is just sign up without the dash, then try without the dash and it should work.
1 second. Let me just share.
Okay.
Okay.
Oh, okay, yeah. So yours will be just sign up without the dash. Give that a try.
So when I go here, it's just 404.
Oh, okay. So within the link, yeah, you're correct. You want to remove the dash in the link, or you can update the directory to use the dash, and then that'll be fine. Yeah.
Oh, I do need the dash.
Rename
Okay.
it. Yeah.
So it's still sign up here, and let me save.
Yep. Yeah, it should be good now. Let's give it a try.
Oh, nice.
Nice. Okay.
All right. Thank you.
Yeah, sure thing. We'll move on to more of the backend capabilities of Next and more server-side rendering.
All right, so we'll break here for 10 minutes, or if anyone has any questions for Paul, feel free to ask. See you guys in 10.
Hey, Paul, is there a reason why we can't just use like a common component directory in Next.js as well, instead of putting it in the directory, like in the directory folders?
That will work as well. If you want to create a directory called common and put your common components in there. What's nice about that is that unless there's a page.js file within the directory, it won't become a.
Okay, thank you.
Yeah. But some of the errors that some of you ran into naming the directory, using the link component instead of navlink with the href. Did any of you actually put a server component within a client component by chance? I actually ran into that error, so but we're gonna get more into that soon. One thing I wanted to mention, if you pull up the developer tools, even though a lot of your components right now are client components, check out the preview. See that at least some of the HTML can be server-side rendered or can be returned from the server right away. So at least the preview tab, which is giving us an idea of what search engines might be looking at least it's not blank. And so right off the bat, we're getting some SEO benefits, even though we're still using a lot of use client directives and whatnot. Also, if you use third-party component libraries like Material UI, React Bootstrap, the community hasn't had a chance to really adopt to this yet. This is very new. If you use those libraries, a lot of those components use state or they're wrapped around use context for like theming or whatever other reason. So even though a component from a third party might seem like it wouldn't have state involved, it's just for templating, like columns and rows for React Bootstrap, for example, it's still using state in some way, and you might have to use client. Like I mentioned, you're still going to get a lot of SEO benefit, so no big deal, but just know that in the future, who knows how third parties might adjust for this. Maybe they're going to provide a version that doesn't wrap a lot of components with use context so that you don't have to use client components, but for now, that's the state of the community. So, okay, I want to talk more about the backend of Next.js because we got Node now. That's not normally a thing that we can utilize when you create front ends without a server. So we're going to be talking about fetching data server side, creating a REST API endpoint. This might be interesting. You can have some endpoints right next to your front end code. So potentially I could move a lot of that Koa code over to Next.js. Environment variables. This is a nice added feature I'm happy to talk about. Reading headers and cookies. This is a thing now that we have a server. And then rewrites and redirects. I threw this in here because there's a really easy way to define these with Next.js. But fetching data server side, if we do not have code that is interactive within the browser, it doesn't require browser APIs. Those are the two rule of thumbs I like. Chances are we can make it a server component, and just because we have a use effect grabbing data doesn't mean we cannot convert that to a server component. So our first step will be removing fetches from a use effect, you can use a regular async function that returns data, assign that to a variable, and then just use that within your JSX that you're returning within that React component. Next.js is doing some caching, and there are also options to update the cache. This is a more of an advanced topic, but just know behind the scenes there is some caching happening. But this is pretty cool. We don't have to use effects if it's a server component. And this means that our data fetching is happening on the server. REST APIs. So you can use a route.js file in place of a page.js file. These two files cannot be in the same directory. It's one or the other. So what I recommend is you use an API folder, and then the route will be /API/ and then whatever other directories you create within that folder. This is going to separate your REST endpoints from your pages. There was an API folder before Next 13.4. So if you remember that, or if you've used Next.js before, I recommend just following this convention. What we're going to do is export a function with the same name as the HTTP method. So the example here is a GET request. You see here we're doing a regular fetch within that's returning and assigning itself to res for response, and then we're also doing res.json for the data, and then there is next response.json as a nice little util to turn our object into JSON and return it. Environment variables. How many of you have had the experience of having to SSH to a server? And I don't know if, yeah, it's a pain in the neck. I don't know if many have done it, but Next.js is a way to work with environment variables in a much better way, and we can keep it within our little framework. So, okay, your .env file, we're used to that. This is for either all environments, or you can specify an env file for development or prod. These are going to be for your environment variables that aren't secrets. These are just common config that we can check in to our code. They are the defined defaults. Now, env.local, these are going to override the previous files if there's duplicate naming of environment variables. But also, this is the file we want to place secrets within, and then add this file to your git ignore, so we're not going to commit secrets to our code repository. But when you spin up your node application, these environment variables are going to be available for your code that runs server side. But if you want environment variables to be available and be sent to the client, you want to use them within your React components, you can prefix the environment variable with next public, and now you can actually use it within code that will be sent to the browser. If you don't prefix it with next public, what Next.js is going to do is, instead of the actual environment variable value, it's just going to input a empty string. This is a built-in way that Next.js is protecting you. It's a built-in way to protect you from sending secrets to the client. Headers and cookies. We're able to read headers easily with this nice function that Next gives us. It's a very simple API. Normally, you just want to get the value. Here's an example of that. And then the same for cookies. So you can see it's just a function where there's a .get and we can grab cookies. The API there's more to the API than this, but it's get set, get first, or it's a very simple API that you can reference if you need more out of it than this, but very handy that Next.js gives us. Rewrites and redirects. We can add these to the next.config.js file. Without even talking about it, you can see how easy it is to define these. You just add your next rewrite within this array that we're returning here, within this async function. Rewrites allow you to map an incoming request path to a different destination path, but the URL won't change in the browser. Versus a redirect, yes, you're going to go to a new path. The URL changes. It's a new page or a different page. But look how easy it is to define with Next.js. I really did appreciate this. Okay, let's refactor to use more server-side capabilities. I'm not sure how far you got in your application, but let's look at probably the first thing we want to do is look for an opportunity to give me a second here. Okay, so page, and I didn't get all the way. Let me see where I'm at with mine. So I didn't finish this completely. Let me just go back to the dashboard. Hold on. Let me just back up. Okay, so I think my application was rendering fine without this. Let me just get rid of the navbar for now, so my application will render. Okay, so the problem is I'm using a server component within a client. I still have to do a little refactoring, but give me a second. Okay, so here we're okay, I'll fix this in a minute. Somewhere I'm using a server component within a client, which we mentioned we can't do. We have to use the children and pass it along. But okay, you can see here, instead of a use effect, let's compare this to my other page. I have a use effect. We're grabbing the data, and then when that data finally arrives, we're setting books. Okay, in place of doing this, we could just write our fetch requests here. I have it all on a single line, but there it is. It's just what would otherwise be. Actually, one thing I did instead is, instead of using like local storage, I'm grabbing the cookie value. I can post this in chat, but you want to get the session instead of using local storage. That's one thing you got to think about when you're developing code on a server. When they hit this endpoint, like in the client code, I can easily, within the fetch requests, look at local storage and pass a cookie or something, or pass a token of some sort. But people are navigating to this endpoint directly. So yeah, there's not like a React component loading first or something where I can do that. So in this case, I'm using a cookie to grab the value. Within my single page application, I set both the cookie and the local storage value. I'm using both, but this is how we're going to start thinking about building applications differently, because we're in a different environment at times, the server. Okay, but other than there being a failure, I can just use this data return from the fetch request right within my JSX. We talked about like reading cookies and headers if we need to. This nav bar, I was looking at this before I had the login button code right within the nav bar. Right here, I'm using local storage and then moving a cookie, using the navigate would otherwise be fine, but this is browser specific. So looking at this, I'm like, okay, the only place I need the browser code or I need to work with local storage is within this logout button. So I was able to just extract that code and put it within its own little component. This component can remain a server component, and then the login button will now be used client. You want to keep your client components as far down in the component tree as you can, because like I mentioned, once there's use client, then you can't easily include server components, but everything past use client is like a line. Okay, all components past this line are now going to be client components. So yeah, this was refactored to use or to be a server component. I no longer have the use client directive at the top. And then within the dashboard as well, since I don't have to use a use effect, this now can be a server component. But those are the main changes you'll be making. Anyone have any questions around this so far? All right, great. Yeah, well guys, start refactoring your server side, or start refactoring to use more of the server side capabilities, and happy to help where I can. Feel free to let me know if you run into an error. All right, I have a good portion of the app working again and rendering. One issue I ran into is this issue here. So you can't put a server component inside of a client component. So I was trying to include the nav bar with the add books page, and it was giving me a hard time. Since the nav bar is a server component, I was trying to use it within the add books component, or this is what I originally had within the page.js file. But since you can't nest server components, I had to use composition right here. So the page will just have these components side by side. This is a server component, this is a client, and I had to separate the code so that the use client or the client component is by itself without any server components within. So like I mentioned, a little change of thinking of how we're gonna put the app together, but really like to see that now within the network tab, look at documents, at least we have all the content there so that search engines can now grab that. Go to add books. So we're actually missing the content that was client rendered. I didn't get a chance to complete that yet, but yes, at least we're getting some content rendered to the browser, which is nice.
Hi guys, I'm Bhavan. Let's start with the show. First thing first, let's talk about what we're going to talk about. So agenda for this session would be discussing common performance problems we as front-end developers face and the generic solutions for these problems, and then how Next.js is actually solving some of these problems. Then we'll open up for question and answers. And a quick note here, we'd look at demo app with the created with Create React app and optimized version of the same app in Create React app, and some alternatives we can use in places of these apps with Next. And we probably wouldn't be seeing a lot of live coding, as a lot of these topics we're going to discuss about need a sizable app. A simple 1 page or 2 page or 3 page is not sufficient enough to actually calculate the difference in sizes and stuff. And we should be good to live with the demos on network throttling to understand the easier optimizations. Okay, let's go. First session we'll talk about is common problems in SPS we face. And if we look at them, first of it would be the application size. Let's discuss what is application size and why should we care. Traditionally, each page requires an HTML file and a CSS file and some JavaScript files for interactivity. All these files are downloaded over the internet to render the content on the browser. This much we all know. And a generic and a common setup for React single page applications will bundle all of this content into one or few chunks for the whole application. Generally, if you use common configurations with Create React app any other custom boilerplates, or even use rid of bare bones, that is an initial. A lot of us do the same. We bundle all of it. We generally don't think of optimization when we start. We bundle up all the app into one or few chunks and use it. That will greatly increase the application size. Here is a problem. Network bandwidth, obviously we're wasting unnecessarily. So the larger the app, the more time it will take to load. So there is a high chance of getting a white flash before the app loads for the first time, single page app loads for the first time. Once it loads, then it's a piece of cake. It will go smoothly. But loading the first time For a single page application for a B2B app, it might be a good use case. But when you look at something like a news portal or some SEO heavy websites, it's not really a good case for your user to wait for a couple of seconds before they can actually see a simple article. And this will negatively affect, obviously, the user bounce rate. And sometimes it can even affect SEO rankings due to the high load times. So it is a convention that ideal time for a user to see the first render should not be more than 2 or 3 seconds. And the next major problem we see is rendering performance. So let's discuss what is rendering performance. There is no official definition to this, but this can be classified as performance, which can affect rendering of the page content in a smooth way and affect the user experience. Is generally majorly concerned with the real user who is actually using the application and their experience. This sometimes will affect SEO ranking, sometimes it might not. It's not a direct correlation. And make websites manipulate in a way that we can show a better performance than what it actually is with some US practices and some workarounds. That's a different topic to discussion for discussion. Then the major issue we see with rendering performance is with fonts and images. And why is that? Fonts, if we do not use it the right way, we end up rendering custom fonts, heavy custom fonts, which take time to load for the user. Once they're loaded, they're generally cached, but the first time to load, it will take time. And fonts can cause layout shifts, and layout shifts will affect the CLS score. CLS score is one of the web vitals, and Google also considers these web vital scores for page ranking. So that is important. And majority of the cases, if the character widths and heights are not to the standard serif fonts, it will definitely cause a layout shift. And what is a layout shift? I'll show further sessions, further slides. So then we look at images. And images also are assets, static assets, in most of the use cases. And loading them on heavy bandwidths is not good. And this image loading the images also can cause layout shifts if not done, if not used the right, if not rendered the right way. And a simple mistake a lot of us do when we were juniors and even when we were seniors is loading wrong images to the wrong devices. There is no point rendering a retina display resolution image to on a mobile device. There is no point. And we will discuss about the workarounds for this issue in coming sessions. And next major problem that we do see for single page applications is search engine optimization. In short, we call it SEO. What is SEO? For some people who are not familiar, whenever Google, not just Google, any search engine robots scrap the website, scrap the internet, they come to our websites looking for content and metadata to index and basically maintain records of websites and web pages to display to their customers when they search for something. And when they and any natural inbound traffic to our pages, it looks for generally the content and sometimes descriptions of the content. And there's a lot of metrics that they look for to rank our page. And majorly it is content and metadata. And whatever we provide these robots, these search engines, they consider that data for their ranking. And there is no doubt Google is a leader here in this space, the search engine space. Google search engine calculates the ranks of the pages with a lot of criteria. If I'm not wrong, there's more than 120 or 130 different criteria that they use to calculate define a page rank for a particular URL. And usability of the web page is one of the major metrics that they consider. It has a definite weightage. How much we don't know. It's obviously proprietary, and that will affect the page rank. And a specific. And now we understood what is SEO. Now let's look at the problems of single page application in terms of SEO. So when you look at our domain and some article, no point when you have a single page applications, you generally don't render the metadata or the descriptions or the content on the first load. First load generally has an empty HTML, as Paul mentioned in his previous session. Generally, it is an empty page with no data, no content. Then on the front end, we build all the content based on the route and based on the data we need. We build all the content on the page and attach to the page. Robots that scrap our website, they don't really wait that long. They expect data and metadata on the first load if we provide it. So single page applications specifically handle all the data on the client, while the old way of renting web pages, the server rendered pages, if you look at any older frameworks, they generate all the content at the server and then deliver it to the deliver it to the client directly as HTML. So that is generally available on the first load, and that is a major problem for SEO and for single page applications. So it's not just about metadata that is the issue here. So for some web apps, it's not really a problem. For the use case of web apps where it's let's say a SaaS app or a B2B app, majority of the pages are protected, so it's not really, they don't really need SEO. So for them, it's not really a big problem. But for the use cases of, let's say, any public websites like a news portal or any other marketing website, this is a big problem. It can be a life and death situation, and SEO considers these this metrics called web vital scores, and they do hold a certain weightage in determining the page ranks. And basically, these web vitals just decide how usable your website is for a general user based on a lot of factors like load time, largest meaningful find, cumulative layout shift, or input delays. And there are a lot of other web vitals also, but these are the major critical ones. And why should we care about web vitals? Not just CLS and other web vitals as well. So I'll just quickly show what can happen with a bad CLS. Okay, this is the UI on page load. This is the content that I see, order confirmation. I have 56 items. Now I either can place my order, I can go back. So I try to come to the go back button and click. But with a bad CLS, what happens is there is some other content of the page that loaded slowly for some reason. Let's say there's an image or some asynchronous action that loads content here, and that at the same time I clicked on the go back, but by that time the page has shifted, and right under my mouse pointer the submit order button has come. So that is a bad use. Now I can't do anything, and it's actually taking the wrong interaction that I didn't intend to do. That is one of the very simple use cases, but there will be a lot more use cases where CLS is the layout shifting is a big problem. Imagine it's not just an order. Imagine it's a money transfer application in a, let's say, banking application. That's a very bad UX, and that can actually cause the real user major problems. That is why we should care, and that is why Google also care about the layout shifts. And with bad layout shifts, it will definitely increase or reduce your page scores. So those are the major problems that we discussed: the application size, rendering performance. And in rendering performance, we were looking at fonts and images specifically. Then we got search engine optimization. These three are the general major problems in single page applications. And now we will look at some of the common workarounds for these problems. First is application size. So a lot of this is a common ground. When you talk about code splitting, it will imply application size improvement. When you talk about application size code split, it implies code splitting and a lot of other things. So when we talk about specifically about application size, simple thought here is, what do you want to load all the application when you all you need is current page? So ideally we should be splitting our code, and we split our code based on pages, based on components, based on basically whatever we need, we just keep that. Whatever we don't need at this point of time, by we I mean the user who's using the application, there is no point keeping loading all of that and wasting bandwidth. So instead of the general regular default configuration is one big chunk of JavaScript, instead of doing that, we should be splitting it into multiple smaller chunks and load them on demand. And code splitting is what we do, and one of the ways of using it is lazy loading. And it can basically, we should dynamically import on demand whatever data, whatever JavaScript or any code that we need, not just JavaScript, any asset also. We should only ask for it only when we need it. And ways to split the code, there are multiple ways in React to do that. Not just in React, even in any web front-end application, there are multiple ways of doing that. So a lot of times we have different conventions. The major ones are we split by page, or we split by components or features. So it's all about when it's up to you. Like, let's say you have a tab, you can even code split the tab into each tab content, and you can render that on demand. But that there you might be sacrificing some blank screen for probably a couple of milliseconds. If you are ready to, if you want to compromise on that for performance, that's up to us. So we should be doing it if it's really that important. And it's all about how granular you want the code splitting to be. Let's look at a quick. I've made a simple list page. It's like a news. It's actually real news. I'm using some third party at the backend to fetch the top headlines in the US. And we'll look at, I disable the cache, and I even throttle slow 3G so we can actually see what's happening when we do this. When we refresh the page, I'm refreshing the page. So I'm using Tailwind for this. So please ignore that, and please don't count those numbers in. It already took 2 seconds for Tailwind only. I'm simulating a slow 3G internet connection. So these numbers like drastically inflated. Even a decent internet would not take like 30 seconds or something. So let's not look at realistic numbers. Let's look at only JavaScript first. Then this is the non-optimized app, and I seriously tried to code very bad application, and you can see that it looks very bad and ugly. So let's look at only JavaScript. So now we've got one bundle, major bundle, which has code for this particular application has only 2 pages. One of them is a home page, and you click on one of these, that will render that particular article. Only 2 pages it has, and this will have all the code, one bundle, then some Tailwind CSS related script. Yeah, both of these are Tailwind scripts. And now I have the same application, and this may look a bit more polished, but we'll again look at the same assets. We'll understand difference. Here I did a code splitting using loadable. I'll show the code also in a minute. What is the difference here from the previous app? When you look at only the CSS, I actually split the code, the home page. So if you look at SRC pages, home chunk, there's a different chunk. Then again, this article card is something I again code splitted, and that actually is put into a different file. So let's say if this particular article card is not visible on this screen, so there is no point loading it. For that also, I'll show an example. There is a footer here that I intentionally hide it, And this component is not in any of these files at this moment. When I click on the show footer, it will actually show the footer, and that footer will be downloaded over the internet. Let's look at the same in the unoptimized version. This is already there as part of the code. So the moment I click it, it just shows the footer. But here in the optimized version, when I click on the show footer, it actually sends a network request because the footer component is then it's into a different component altogether. So you can look at this. When I clicked on the footer, show footer, then this component was internal. If you look at the size of it, it's only 1.5 KB. So if you really want to optimize, you can actually optimize even granularly. Like only render the code that you see on the screen, and whatever it's not on the screen, you can just put it in a different code chunk. And I'll quickly show how it has. I have two applications. One is an SPA, one is an optimized SPA. SPA is the one where there's a create React app. Here I have this as part of home.js. And in the application.js, I just imported those files like the regular normal, and we have all of it available in the routes. And this is how we do it in the regular way. Then we can also do that if you want code splitting. The simple thing we can do is I used a third party called loadable. So once you use the loadable component, I basically put them as I use loadable, and loadable will dynamically import this only on demand. I put this on homepage also. It's probably not required because it's an index page, but I still did it just to show there's a different chunking rendered. So when I go to the article page or collection page, then those components will be loaded. So while building Webpack, in this particular case, Webpack will know what are dynamic imports, what are not dynamic imports, and put them on different chunks. And basically, home, collection, and article are put in 3 different chunks. Then currently being rendered, that will be rendered. So that will immediately put things in. I haven't made a build here, but if I make a build, you would be able to see multiple chunks than a single chunk. So this I used for home, but when I went down even further down. So in the home page, I again used article card as a separate loadable component and footer as a separate loadable component. And these are again dynamically rendered on demand. So that is one way of doing it. Very similar way we can even do suspense. We can use suspense. So React understands this component should be dynamically imported. So we'll go back to our presentation. So code splitting can be done with different as we spoke already, I did a demo with a loadable third party, but you can use suspense, or you can use dynamic imports, or you can use other third parties like loadable. Loadable has been a battle tested third party from a lot of time. That's why I use that. And once we do code splitting, what is the outcome of code splitting? As already discussed, as already spoke. So we only download the page skeleton at first, then load only the components on current page or the page related to source code to render the page. We can even, I'll talk about that when we come to next. The outcome of this code splitting is basically you, instead of having 1 or 2 large chunks of code, you split them into smaller and minute. I even remember one time I code split so granularly that for like probably 5 or 10 page application, the chunks were more than 500, like very small amounts. I very granularly I code split. There was a requirement because it was a B2C, and we were serving some internet clients also, so we needed that. So outcome of this particular code splitting is basically we get our app into so many granular pieces, or whatever number of what that we decide those pieces, and we pick them on demand. So the page user experience is not bad. people have at least something on the screen. Maybe there is a millisecond of white flash screen, but at least they'll see the data when and how required. So now we'll look at, there is a common workaround for the application size. One of the ways is code splitting. Now we'll talk about rendering performance. Code splitting and lazy loading go hand in hand. Lazy loading can impact rendering performance also, as well as it is part of code splitting also. So we will discuss lazy loading as part of rendering performance. And when we talk about rendering performance, so we'll talk about fonts first. This is the major, as we already discussed, the fonts and images are one of the major issues which affect negatively in rendering performance. And now we're talking about the workarounds. So for specifically fonts, we should be using, if we use highly available CDNs like Google Fonts, coding services, that is the easiest way to minimize the load times by increasing the availability. And caching the fonts. Fonts are generally cached, but unless we do it the wrong way, we can mess up with the caching. But fonts and other assets like images, CSS files, they're all generally cached. And prefetching is a good workaround to actually improve the performance. Let's say we have some application with multiple pages, and one of the future pages uses some font. We can prefetch that before even going to that page, because all of this will happen in the background. So that will only is available when they reach that page. That will reduce the delay in rendering the font and eventually not increasing the layout shifts. And there is this size adjust and font size adjust CSS rules that are supported in some browsers, which can actually help you with the layout shifts without changing the dimensions of content in drastic ways. We can make use of that. I'll quickly show what I mean by that in the same application. This is the, okay, let's go to the unoptimized one first. So let me not throttle and quickly load some fresh content. Now I'll throttle. So now we go to one of the pages. Let's say this one. This is the default font. I have some serif font, but I actually have a different font that I want this page to use. So I just made a click event. When I click it, it changed the class name and all the font will be changed. By content layout shift, I mean you can see actually the number of lines or the alignment of content that all will change the moment a different font is applied. I just clicked. Okay, this is not part of the unoptimized app, so I'll show it in the optimized app. Here, if I click, there is a different font that applies to this, which will actually render, which will actually result in a layout shift. By that, I mean this, if you notice the number of lines and alignments are changing. Push down, let's say, just like the video we saw earlier, that can actually, it can actually change something like an important call to action button to a different page, and by eventually leading the user to do some wrong interaction. That is the content, the layout shift I was talking about, which can affect because of fonts, since we're discussing fonts. And now let's talk about images render performance. Okay. Something similar again applies here also, because these are assets. If you look at the same application, when I render, I'm throttling it to slow 3G, not even fast 3G. So the image loads in some time. If you look at the page content, initially it is spread for the full page. I intentionally put a bad code, very code here to show the effect it can actually cause if we do bad coding. The image here is initially not loaded, it will take time to load. Meanwhile, when the content was here, it initially, because this is the optimized one. So now let's go to unoptimized one. Here we'll see I render it. Initially, the content will be full width, but when the image loads, it actually, there is a major layout shift that happens on the page, which is one of the vital scores, which can directly impact your SEO as well as user experience. If you looked at that, there was a major layout shift in the number of lines the page has and how it's aligned. So that is again an effect of rendering performance just because of images. Again, here is another. We were talking about probably I was supposed to do this demo when we were talking about the problem. Now that we are here at the solution, generic solution, let's discuss the solution. The one of the problems we discussed was serving wrong images to wrong devices. For that, HTML natively has this src set source set attribute available on the images. If we use that and provide the right sizes and right assets, browser will automatically download only those assets based on the device size. It's almost as very equivalent to, let's say, our media queries. And also providing dimensions to the images when we have them is one way. For example, this image, I do not know the size, but I randomly picked some size and provided it. So it'll at least prevent the CLS, the layout shift that happens. It'll improve the CLS score. Initially, I gave it some width and some height, so that place is resolved, so there won't be any drastic layout shifts. While the image is being loaded, this is the initial render. The content will be there with some parked space for the image to appear later. This is a common workaround by providing dimensions to images and by providing, let's say, loaders like user experience. It'll be easier to counter the render performance issues caused by images. Okay, I'm here. So now this is one of the other sessions that we did not really conceive as a problem when we were discussing in the previous section, but I wanted to add this here. Some of you might know about this pursuit performance. Then we have this regular practice called critical CSS. If you're not familiar, basically critical CSS, this practice is a very common solution that has been in the industry from last, I don't know, probably a couple of decades, since as long as the CSS was there. So basically here what we do is we just pick the CSS that is required, bare minimum CSS required for the first view of the page, and we keep that inline. And inline CSS is not render blocking. So once the page downloads, this CSS comes as part of HTML, and that is rendered quickly on the page. Otherwise, what happens? HTML page comes, then the CSS is externally linked there, and while that is loading, the rendering is blocked. Then DOM is passed, then CS DOM is passed, and all of them are merged, then painted. There's a lot of time that happens. But if you have the first full CSS available as inline CSS, there won't be any blocking, and the rest of the CSS can be rendered in the background over the next couple of network calls. So again, a lot of CSS plugins are available to extract the critical CSS. And then we talk about the search engine optimization. What are the possible workarounds? So this was probably discussed. How do we solve the metadata issue? This is probably discussed by Paul earlier in the previous section. So basically just converting by a single page applications into a server-side rendered application or a server-side generated application will let us solve the problem here. So what is the problem here? Let's quickly show. This is a single page application. I'm getting done with throttling. So when I render any page, this is not really my home page. This is a page. But whenever let's say somebody lands on this URL directly, and the initial content they'll get from server is basically this blank HTML. There is just a div with root ID, nothing else. And when the such scraping robots look at this, they get nothing. There is no content. There is no metadata available. Whatever metadata is always this is basic metadata, and it basically cannot use this page for deciding your page rank. So this is at the moment you convert into an SSR or SSG, all this data will be populated at the server. In case of server-side rendered SSR applications, it will be generated at the server. In case of SSG, it will be generated during the build time. You can customize all of what to be rendered, what not to be rendered. You can customize all of that. And even though there is a slight delay in doing all these actions at the server, then giving you the HTML, that is a trade-off we should be taking for the added advantage of SEO. And in simple terms, the SSR applications, we send the bare minimum content to the client, and client will render that content and metadata, and rest of the application is hydrated lazily. And in SSG applications, all these independent pages are almost like independent HTML pages that are generated. A lot of applications do this. Next does this. Next suppose that even frameworks like Gatsby and all do this. So the metadata issue should be solved just by converting into server-side rendered or server-side generated application. And the next problem with SEO we faced with SEO is Web Vitals. We need to improve the Web Vitals so that our page ranks better. So as we already spoke, Web Vitals are basically the parameters, the metrics that Google uses, specifically Google uses to decide on the page ranks over a certain weightage. And the critical Web Vitals that actually can decide your page rank are these three. The LCP, largest contentful paint. As the name suggests, it's basically a metric to calculate the loading performance. And according to Google, initial content should be painted on the screen under 2.5 seconds from the page request. Lower the time, better the score. Then we got FID, which is first input delay. This is the metric that Google uses to calculate the interactivity of the application. The delay in the first interaction for the user ideally should be 100 milliseconds or less when the page is painted. The lower the delay, the score is better. Then we have the very important metric that we can control by simple workarounds, which is the CLS, cumulative layout shift. This is the visual stability metric, just like we saw in the video example earlier. Just because of that stability issue, a major issue happened for the user. Instead of canceling, they ended up ordering, checking out the products. That was just one simple example, but this is the stability metric that Google calculates to decide on how usable our pages, and 0.1 score is the ideal score. It should be below that. And this, as we discussed, this can cause majorly due to revealing contents, like you have some promotion happening and that suddenly appears, and that disturbs the whole page to shift a bit, maybe for a couple of pixels, or not rendering images in the right time, or not rendering the fonts in the right time. These are basic majority of the use cases. Let's discuss how Next.js is solving these majority of these problems. So first thing first, app size, by providing ability for you to convert everything into SSR or SSG easily. And Next.js by default, as Paul already said, is server first. So SSR and SSG are the default process for your brain to start with next. And together with server components and suspense, Next splits code and loads the rest of the app as and when necessary. So it basically deals with both code splitting and lazy loading at the same time, and that will impact our app size directly. Then we talk about rendering performance fonts. Next has provided this utility Next 13 Next/fonts, which will solve our problem. This serves all the Google fonts as first code in priority, avoiding the network request for fonts. This has self-hosting, built-in self-hosting. So all the Google fonts are internally how they are done. I'm not 100% sure either the caching or they're doing a faster hosting. And it internally uses this component internally uses the size fonts that just CSS for font switching. So without the drastic switches, there won't be a lot of layout shifts. So this also supports custom fonts along with Google Fonts. You can provide your own fonts, and this will provide that as part of the self-hosting. That will increase the CLS code definitely, if that is a problem in that particular application. And then we talk about the rendering performance for images. Similar to fonts, Next again introduced this image component. And this does a lot of optimizations. This by providing source sets, this actually serves the right size images to right devices internally. We don't have to set up anything. We don't have to do a lot of optimizations ourselves. This is all provided by Next by default. It prevents the layout shifts automatically when loading images, so we don't have to worry about dimensions and possible potential layout shifts. And this increases page loads. It is increased page loads by using the native lazy loading ability of the browser. Basically, whatever is not in the viewport, it does not load that image. So when you scroll to that place, it lazily loads that image. That will basically reduce the initial page load time. And if there are images that you're hosting locally, the images are automatically calculated for dimensions. You don't have to provide dimensions. And you can also set priorities, prioritize important images loading first by setting the priority prop. A lot of other cool customizations this particular component provides. And skeleton loaders are available for images to use while loading. And source sets are also optional. If you need to use them, you can use them, but they're inherently supported directly. And Next.js, how it deals with perceived performance by lazy loading. Lazy loading is a solution for a lot of things, not just perceived performance. And on demand and on view, but only there it renders the images as we already discussed. The same even applies for the components, the client, all the client components that Paul spoke about earlier. All the client components, they are lazy loaded. Not every part, not every code is loaded, and splitting is supported by Next.js by default by page. The nomenclature they choose this by page. So each page is a separate. Each code for each page is a separate chunk. It by default provides that. Next has been providing that from even from the inception of Next, not just Next 13. And when you talk about SEO, since SSGSs are supported by default, since we have that facility, we don't really have to worry about SEO when you use Next, because you can control all the metadata and all the content, and you can generate at the server. So we really do not worry about SEO when you use Next.js 13. We don't have to set up anything extra other than whatever is Next providing. And by using even the font and image utilities that Next provides, most of the common issues are resolved. And that will improve a lot of times, not just the CLS, and also lazy loading directly affects both CLS as well as file loading speeds. And that all will directly impact SEO. So the content is served from the both So we served at the from the server in both case of SSG and SSR. And the metadata can be customized at build time in case of SSG or at runtime at server in case of SSR. So the issue with SU is solved. Thank you, everyone.
Yeah, this was really good, Bhavin. But the cumulative layout shift, I see that
Yeah.
all the time. It's quite an issue. It's nice that with Next.js you can just render a lot of that content from the server so it doesn't happen as much.
Actually, my favorite part with Next.js Next 13. It's really very useful for a lot of front-end applications, not just any application. You want to discuss deeper? It's a big topic in itself. The CLS, just the CLS, not don't even think about the LCP or the FID. CLS itself is a deeper topic to discuss. So yeah,
Nice. I really liked your example too. Like that really can have a big client impact. So if the content's moving on you. So
yeah,
great talk.
sure, man.
For coming. I'd like to have a big thank you to all of the participants, Bhavan and Paul, and Miles, myself for participating, putting this together. Thank you, Parag and InRhythm for hosting, and we'll see you all next quarter. So thank you. Parag, do you want to?
Thanks. Yeah.
Closing words.
Thanks, Kevin. I'll wrap it up quickly. Again, like Kevin said, thank you all. It was really awesome. Thank you all for participating, and special thanks to Kevin, Miles, Bhavan, and Paul for putting together this workshop and doing an amazing job with it. It was really informative. I hope all of you enjoyed this experience as well. As a part of the technology summit that we are hosting for summer 2023, we are hosting a series of 6 hands-on interactive coding workshops on some of the latest technology trends. And our next workshop in this series will be hosted next week on Thursday by our DevOps practice, where we'll take a deep dive into modern full stack observability. Full stack observability is needed for every enterprise to truly evolve and harden their system on all fronts, from infrastructure to the application. And today we have several tools available that will help with application matrix, logs, event traces. But any organization can easily get overwhelmed with the number of tools, as well as in current economic conditions. We need to be careful because a lot of these tools could really quickly exhaust your financial resources as well. So in this workshop, we're going to discuss open source technologies to achieve full stack observability using Prometheus and Grafana. Those are the two tools that we'll be focusing on, will be useful for all of you across different technology stacks. So I'm really excited for this workshop. Make sure you mark 7th of September on your calendar, which is the Thursday of next week. And thank you all once again for joining. Have a wonderful evening, and I'll see you guys next week.